The second we hit the division rule of exponents, we run into some interesting cases. So now we have to talk about zero and negative exponents. Let's simplify each expression. X to the 4 over x to the 4. So we have x times x times x times x over same thing on the bottom. Well, what happens? You have the exact same thing on top and bottom. Everything cancels, and you're left with 1 over 1 or just 1. And in fact, we didn't even really have to write out expanded form, right? Because we know that if you divide anything by itself, you get 1. And now we're going to go on to something that we saw actually in a previous video, which was x squared over x cubed. So you have x times x on top, x times x times x on the bottom. Two of those x's on top and bottom cancel, and you're left with 1 over x. Well, let's compare both of these to what would have happened if we used the exponent rule. Well, x to the power of 4 divided by x to the power of 4 would be x to the 4 minus 4, which is equal to x to the 0. So x to the 0 is equal to 1. Similarly, on the other side, if we had done x to the power of 2 minus 3 using the division rule, we would have gotten x to the power of negative 1. And that's equal to 1 over x. So we can see there's some interesting properties for exponents of 0 or negative numbers. The zero exponent rule says that anything to the power of 0 is equal to 1, for the very reason that we saw in the previous slide. So here's a few examples. 5 to the power of 0, that's equal to 1. Negative 16 to the power of 0 is actually a little more interesting. We have to go back to the rules of BEDMAS. When you look at an expression and you want to simplify it, exponents comes before, or just after brackets and before everything else. So negative 16 to the power of 0, well, you have to deal with 16 to the power of 0 first. So 16 to the power of 0 is just 1, and you still have that negative sign. So you have to deal with that exponent first and then the negative sign after. So it's actually equal to negative 1. So that's the interesting case where you have to be careful with 0 powers. Lastly, negative 3 to the power of 0, well, because we're told brackets comes before everything, that negative 3 is in brackets, well then anything to the power of 0 is equal to 1. The negative exponent rule says that x to the power of negative a is equal to 1 over x to the power of positive a. So that negative exponent is essentially representing that the power is in the denominator. Another way to write that, we can do the opposite, is that 1 over x to the negative a, so now that negative exponent's in the denominator, that's equal to x to the power of a. So what we're going to do is we're going to simplify each expression so that all the exponents are positive. So x to the power of negative 3, well, the negative exponent rule just says that that's equal to 1 over x to the power of positive 3, or 1 over x cubed. Similarly, if we have 1 over m to the negative 5, well, we flip that, so we have m now in the numerator with the opposite sign for the exponent, which is positive 5. So 1 over m to the negative 5 is m to the 5. This last one's a really complicated one, and we have to break it down in chunks. So we have two fractions. We sometimes call these complex or nested fractions. And so here's the first fraction we have to deal with. We have 1 over 4 to the negative 6. Well, we can write 1 over 4 to the negative 6 as 4 to the positive 6, as we saw using the previous rules. we flip this fraction and make the exponent positive. Well, now we have 1 over 4 to the 6, and because our goal is to leave the exponents positive, we're done. That's as simple as it can be with a positive exponent. But we could, if we wanted to, write this as 4 to the negative 6. So now we're really starting to fill out our rules for exponents. We have the multiplication rule, the division rule, and now we've talked in a little bit more detail about the zero and negative exponents rules.